So welcome you all in the contact session number 13. So in the last class, we have started the interval estimation. So I already told you there are three types of estimation we are doing here. First is point estimation, unbiased estimation that we have done. Second, we are doing the interval estimation, and third is we will do the hypothesis testing. Correct. So now we are doing here interval estimation. So first part of the interval estimation we have done. So you can see this graph or this flow chart. So you can see that firstly we are just checking at the population standard deviation sigma is assumed to be known or known, not known. So if that case we have done, yes, we know the standard deviation sigma. So we can use the interval estimation x bar is equal x bar plus minus z alpha by 2 sigma upon root n. So in the last class we have done this part. Okay, so now we are just extending that part in the right hand side. If sigma is not known to us, so we are using the S, that is the sample standard deviation, to estimate sigma, and then we can use this definition, the T alpha by 2. Okay, so T alpha by 2, that is coming from the another distribution which is known as the T distribution. So Z alpha by 2 is coming from the standard normal distribution, but T alpha by 2 is coming from the T distribution. Okay, so firstly we will discuss about a brief introduction of the T distribution, and then we can use this T alpha by 2 in this formula. Okay, formula is almost same. What is the difference? Instead of sigma, because sigma is not known to us, so we are using the S, that is the sample standard deviation, S, and then instead of Z alpha by 2 we are using T alpha by 2. Correct. T alpha by 2 is coming from the T distribution. So interval estimation you have already defined, I already defined here, x bar plus minus margin of error. So if sigma is unknown, so we are using the T distribution here. Correct. In this one, we have also considered one important assumption, that population should be normal distributed. If it is not given, then we can't apply the T distribution. Now, what is the meaning of the T distribution? So if x1, x2, xn is a random sample of size n, it is important from a normal population. So these are the two important points which we are mentioning here. The size should be n and the population is from normal distribution. So with mean mu, so mu is unknown for us. So that's why we are trying to find out the interval estimation for mu here, and sigma is unknown. Correct. So x bar minus mu upon s upon under root n, that follows the T distribution with n minus 1 degree of freedom here. Okay. So in the T distribution, degree of freedom is the parameter, and it is n minus 1 degree of freedom here. Okay. Now, properties of T distribution, we are not just going in the very much detail of the T distribution, because distribution part we have already done. So we are just using the some properties of the T distribution so that we can identify that where we have to apply the T distribution. Just an application of T distribution we are doing here. Okay. So Tn denote the T distribution with n degree of freedom. Correct. Each Tn curve is more spread out than the standard normal Z curve. So curve is almost same, but that is more spreaded out. Okay. As n increases, the spread of corresponding Tn curve decreases. Okay. So it depends upon the spread here. We are saying here like this one. Oh, sorry. So let us suppose this is the curve. This is more spread out. When n is increasing, so it will become like this one, and the peak is more high than, or like this one. Okay. So that is the concept which we are using here. So as n tends to infinity, okay, where it means n is very large, so sequence of Tn curves approaches to the standard normal distribution curve, and then we can say, so Z curve is often called the T curve with degree of freedom infinity here. Okay, so notation we are using T alpha n. So as we are using the Z alpha, same here we are using T alpha, but we have to just define the degree of freedom also. So you can say the number of measurement axis for which the area under the T curve with n degree of freedom to the right, that is T alpha n is alpha here. So what we are just trying to say here by the probability concept, probability when T is greater than equal to T alpha with n degree of freedom is equal to alpha. Okay, so the curve is like this one. So we are just saying here this part is T alpha for degree of n, and this area is alpha here. Okay, so this alpha is coming from that right area, the area of the right part of that point here, this point. Okay, so example T of 0.05 of 6. So here degree of freedom is what? 6. N is equal to 6 here. And the T critical value is what? Here this alpha is 0.05. So this area, left hand, the right hand side, this area is 0.05. Okay, with 6 degree of freedom here. Now we are using the sum proposition when interval estimation for mu sigma unknown. Okay, and small sample size, because if large sample size then we have to use a Z test. We have already done by central limit theorem. That part we have already done. Okay, so let x bar and s be the sample mean and sample standard deviation. Sigma is not known, so we can calculate the s. S is what? Sample standard deviation. And we have just computed a random sample of size n from a normal population. That is very important. So 100 into 1 minus alpha percent confidence interval can be written as x bar minus T alpha by 2 and minus 1 degree of freedom with multiply of s by root n. Similarly, x bar plus. So what is the difference? The left bound is minus, right bound is plus here. So our plus minus margin of error. What is the margin of error? T alpha by 2 and minus 1 degree of freedom s upon root n. Okay, so more compactly we can say x bar plus minus T alpha by 2 and minus 1 s upon root n here. So this is the distribution. Any query? So we have done the two type of distribution, x bar plus minus z alpha by 2 sigma upon root n. Okay, and that next we are saying x bar plus minus T alpha by 2, and in this one there is a parameter also, that is the degree of freedom with n minus 1 degree of freedom s upon root n here. Correct? Slides are not moving. Just wait. It's not responding. Just give me 1 second. There's some problem. Are you, am I audible here? Okay, fine. Just give me 1 second. I think it's not sharing. I'm just trying to connect it. Are the slides visible now? So you can see the table. So this is the t distribution table basically. Okay. So in the first row, you can first column, you can see here new. New is what? The degree of freedom. This is a t distribution table. Okay. And the critical values are given. So alpha is equal to 0.1, alpha is equal to 0.05, 0.025, 0.01. Okay. So these alpha values are given. So it means what? If we are saying t 0.05, if we are just saying the previous one, it is 6. So degree of freedom is 6 here, degree of freedom is 6 here, and we are just saying 0.05. So this is the second third column, and the value is 1.943. This is the way to see the table. Okay, t distribution table. Are you able to get? Is it visible to all of you? So here we are seeing the degree of freedom 6 here, and then alpha is equal to 0.05. So it is 1.943. Okay. Now we are doing some similarly when we will do the questions. So we will show you the values here. Okay. Now come to the example for finding the confidence interval. So 7 laboratories experiments of the value of G. So N is equal to 7. It is given. Due to gravity that follows the normal distribution. The proper population distribution is normal distribution, and the mean is 977.51. So what is given here? If we are just going back, so n is equal to 7 is given, correct? Dot distribution is normal distribution for population, correct? And x bar is given 977.51. And the sample standard deviation is S, that is S, that is given as 4.42. Okay. Find 95% confidence interval. So 95% confidence, 95% confidence interval for mu, sigma unknown. Sigma is not known to us. Okay. So now we have used the, because sample size is small, distribution is normal, population distribution is normal. So we are using what formula? X bar plus minus T alpha by 2 with n minus 1 degree of freedom S upon root n. Correct? because here s is sigma is not known, so we are using s, so we are using the t distribution. Now we can just here what is given, n is equal to 7, x bar is this, s is this, and alpha is 0.05. ठीक है ना? अब alpha is 0.05, so we need to add t alpha by 2 with n minus 1 6 degree of freedom. So if we are just going back to the table, so we can just say alpha is equal to 0.05. So alpha by 2 is equal to 0.025, correct? And n minus 1 is equal to 6. The 6 degree of freedom. So we have to find out T alpha by 2 with 6 degree of freedom. So here what we are taking 6 degree of freedom is this, and T is alpha is 0.025. So in this one, in this column, we are just checking. So it is value is 2.447. Okay, all information is given, plug in the values in the formula and you will get the answer. So x bar is given here. If we just go back, x bar is given here. So the t value which is required is this. So x bar minus s upon root n t to 0.025, and this value you can substitute. So you can say here the value is what? 977. 0.51 plus minus, so plus will give the right hand limit and left is the lower bound limit. Okay, plus minus 2.447 multiplied by s is what? 4.42 divided by square root of n is what? 7, so square root of 7. This you can find out, and this will give 973.09 and 981.93. So this is the confidence interval. Correct? Any doubt here? If any student having any doubt, you can tell me. We can discuss here. So these are the another example to estimate the average number of pounds of the copper recovered per ton of ore mine. The sample of 150 tons of ore is monitored. Sorry. Okay, we will see. But according to me and according to the course content, it was not difficult. We are trying to make it more as simple as possible. So sample mean is given 11 and standard deviation is given 3. Okay. Construct a 95% confidence interval for that. Okay. So population not given as normal. It's not normal, but n is equal to 150, so it will become more large values. X bar is equal to 11, s is equal to 3, and alpha is 0.05. Correct? Alpha is 0.05, so we required the value of t of 0.025 with the degree of freedom 149. But if you're just seeing the table 149, so after 29 they are not giving the value, because what we are saying, if it is more than 30, so we can consider n is large, and that we can say that it is converging to the standard normal distribution. So it is infinity, means 149 we can consider is infinity, and this value is coming here 1.96. Okay. So after 30 the table values are not provided basically. Mr. Venkata, actually the comprehensive examination is the open book examination. Okay. So you can see these values from the textbook. So I just copied pasted this table from the textbook only. Okay. So, Mr. Gaurav, what we are saying here, n is very large. So, as I told you in the last slide, that if n is large, then t distribution will converge to the z distribution. Correct. So, if n is more than 30, then we are using the values from the z distribution itself. Yes, Mr. Vishnu. Yes, you have to refer always the value of the from the table, just like a standard normal distribution. Z distribution, we will do the example later on. Okay, so in this question we are saying it is 1.96. Now we can substitute the value x bar, we know s upon under root n 0.025, and then when we are giving the value. So again I am writing the information here. The formula is what? X bar is 11 plus minus what is the value here? 1.96 multiplied by s. S is what? 3 square root of n, that is 150. So from that you can get the value here 10.52 and 11.48. So that is the 95% confidence interval for mu when sigma is not known. Sigma is not known, so we are using the S. Okay, we are using the S instead of sigma, and instead of Z we are using the T distribution. Okay. Now they are asking 95% confidence interval for polymerization. 1 minute, one example. So in this one, n is equal to 17. We are taking a one more example, and x bar is this. S is equal to 15.14. Now you can say this is n is 17, so it is very small, and sigma is not given. S is given here. So we are using the T distribution. So T distribution will says here 438.29 plus minus T alpha by 2. T alpha by 2, so it is 0.025, and degree of freedom, because n is equal to 17, so we are taking 16 into S. S is 15.14 upon square root of 17. Okay, and this value is coming from, because 16 degree of freedom and 0.025, so it is 2.120. So you can plug in the values and you can find out the answer here. So 438.29 plus minus 2.120 multiplied by 15.14 square upon square root of 17. So the answer is coming here 430.51 and 446.08. Here 16 is given, is 17 is given in the question now. N is equal to 17. So this is n minus 1. Whatever n, that is minus 1 we are taking here. Okay, so these are two more examples which you can just do it your own. So now there are two specific points as we have discussed. N is greater than 30, large sample size we can consider, but variance known means, variance known means what? T value you can see from the table. Okay, so sigma is given here, so we can use the central limit theorem and we can use the Z test. Okay, if n is greater than 40, so it is also very more large, but variance is unknown. So we are using sigma, instead of sigma square we are using s square, and we are using the again the Z test. Okay, so instead of T we are using here the standard normal distribution, that is Z alpha by 2. Z alpha by 2 instead of T alpha by 2. To T alpha by 2 in only one case we are using, when n is less than 30, population is normal. Okay, and sigma is unknown. Okay, so then we are using the T distribution, otherwise we are using the Z distribution. Okay, so that is the same here, that if Sigma is not known, so we are using S, but N is greater than 40. So by using the central limit theorem, we are using the Z alpha by 2. Okay. So it is the same formula as we have done in the last class. X bar plus minus Z alpha by 2 S upon root N. So now we are doing a one more example. One example we have already done. A random sample of 110. So N is equal to 110. So it is more than 40. So we can use the CLT. Okay. So resulted the average radar echo duration is 0.81. So X bar is given 0.81 and the sample standard deviation is 0.34 second. So here sigma is not given. So we are calculating the S. Okay, so S is provided 0.34 second. Now we have to calculate 99% confidence interval for the true average, okay, of the duration. So for 99%, you can say alpha is equal to 0.01, and when we are taking alpha by 2, that is 0.005, and we are just checking for that. CLT, that is the central limit theorem. Central limit theorem we can apply when N is greater than 30 and 40. Okay, greater than 30, so sigma is known. Greater than 40, when we are using sigma unknown. Okay, so 99% confidence interval for mu is the same as we are saying X bar plus minus Z alpha by 2 S upon root N. We can substitute the values here. 0.81 plus minus, here this value is 2.58. 2.58 you can find out from the standard normal table, which we have done earlier so many times. Okay, book chapter, this book chapter. Okay, I will tell you. Firstly, I will just complete this question. S is what? 0.34 upon root N. Root N is what? 110 here. Okay, so that is we given here 0.81 plus minus 0.08. So 0.81 is X bar and 0.08 is the margin of error here. Mr. Vishnu was saying it is chapter 7. Okay. Some more example here. So we reported for a sample of 50 kitchens. So N is equal to 50 here. Gas cooking appliances monitored during the 1 week period and sample mean is what? 654.16. Okay. And sample standard deviation is given 164.43. 95% confidence interval. So which formula you can apply here? That is Z distribution is the same here. Why? Because N is greater than 40. Okay, so it is 50. So that is why we are using the same formula. Formula is what? 654.16 plus minus. This is Z distribution. So here it is 1.96 multiplied by S 164.43 square root of 50 here. Okay, 1.6 is Z alpha by 2, which we have. Z is unknown. You have to calculate this value of Z by using the standard normal table, Mr. Sanjeev. Okay, so this is the alpha is 0.05. So based on that, 1.96 in the last. For N is equal to 150 also, we have to use the Z distribution. Directly it is coming in the infinite. The values are given for the Z distribution only. In the T distribution table. N is greater than 30, then we can just reach to the directly Z distribution. So that value is given from the Z distribution, the same value we have used. Okay, Mr. Randhir. So the answer is coming 608.58 and 699.74 here. Now the next point is determining the sample size. Okay, so E is the margin of error, sigma is known. So if E is the margin of error and sigma is known, so X bar plus minus Z alpha by 2 sigma upon root N. This is the formula. This is the margin of error. This is E. So we can say E is equal to Z alpha by 2 sigma upon root n. So if sigma is known and E is also known, so we can find out the n. Alpha value, okay, so it is given 95% confidence interval. So it is 100 into 1 minus alpha percent confidence interval. Okay, so you can say here 1 minus alpha is equal to 0.95. So alpha is equal to 0.05. Okay. So if E is given sigma upon root n Z alpha by 2, so n can be find out from this formula, that Z alpha by 2 whole square sigma square upon E square. So one example we are taking here, helium porosity in percentage of coal sample taken from any particular seam is normally distributed. So this is given. True standard deviation is 0.75. So sigma is given as 0.75. Correct. How large is sample size? So they are asking what is the value of n necessary if the width is 95%. So 95% means what? Alpha is 0.05. Interval to be 0.40. So 2E is equal to 0.40. Margin of error. That type of question we can't do, because at the time we have to use the T distribution, and in the T distribution we require the degree of freedom, and that degree of freedom is not provided because we don't know n. Okay, so if sigma is unknown but still we can find out the n, it's not possible at all. Alpha by 2 is 0.025. Correct. E is the one-sided margin. Width is given. Width is given, the complete width. So plus minus we are doing now. When sigma is known, then it is 30. If sigma is unknown, that it is 40. In one slide, we have mentioned is clearly when we are using n is greater than 30 and what is n by 40. Alpha is coming from here, 95% confidence interval. So as I told you here, 95% confidence interval. So 100 into 1 minus alpha percent confidence, we compare it. So 1 minus alpha is 0.95. So alpha is 0.05. Okay, so Z alpha by 2, so many questions we have already done for 95% confidence interval. In one table in the last class, we have already given these values. Okay, so 2E is equal to 0.400, sigma is given, n is given. So by using the direct formula, n is equal to Z alpha by 2 sigma upon E whole square. So we substitute in this one and we are getting n is equal to 54.02. So now we have to go more than this. Okay, so that's why n should be 55 if the width is required as 2 times of 0.40. Because sigma is not known and sigma is known, that is the problem actually, Mr. Arjun. So that's why we can't use the same formula. Now same thing, suppose investigator had rough guess of 175 of the values of S. So S is given as 175. What sample size? So it means n is there required, would be necessary to obtain the interval with width of 55 pm. 50. Okay. So now this is the rough guess it is given. So we can use the W and we can use the Z distribution here. And in that one, we are finding that n is equal to 188.24. So it always coming more than 40 actually. Alpha is not equal to 95 by 100. That is 0.95. Okay. In which formula? Root n. Root n formula is what? We have already done. Or you can say like instead of E, we are saying 2E, that is the W, is equal to Z alpha by 2 sigma upon root n. So from that, root n is equal to Z alpha by 2 sigma upon W. So from that, we can find out n is equal to Z alpha by 2 sigma upon W whole square. This is the formula to calculate the sample size. If sigma is not given, so we can use S, sample standard deviation, but at a time n should be greater than 40. It is coming by the formula. Okay. Now we have done the confidence interval for mu. Now we are doing confidence interval for sigma. That is also a population parameter. Okay, so till now we have done the sigma is known or sigma is unknown. So we are finding the confidence interval for mu. Now we are doing the confidence interval for sigma here. Okay, so I'm just taking a 1 minute break. I just want to drink water. Then I will come back. You can go through the slide here. So here we are using the chi-square distribution. Do you remember the chi-square distribution that we have done at the time of gamma distribution? Do you remember? In the gamma distribution, two special case we have done. One is chi-square distribution and second is exponential distribution. So we have not done any question related to the chi-square distribution because chi-square distribution is coming in the statistics, because we are using frequently in the statistic for sigma. So that's why we are not doing any questions at the time when we are doing the gamma distribution. So we are doing a gamma distribution and exponential distribution, but chi-square distribution is also a special case of the gamma distribution. Okay, so here we have done Z distribution, we have used the T distribution, now we are using the chi-square distribution. Okay. I'm not audible. So here we are saying sigma is also known, so unknown. So we are finding the estimation of variance. So we have done estimation of mu. Now we are doing estimation of variance, correct? So we have already defined that S square is an unbiased estimator of sigma square. Do you remember the unbiased estimator? Point estimator we have done. So unbiased means what? Expected value of S square is equal to sigma square. That's why it is known as unbiased estimator for sigma square. Sigma square is not known to us. So by the definition, we calculate the expected value of S square. And that is coming the sigma square. That's why it is defined as an S square as an unbiased estimator. Correct? Where expected value of S is not equal to sigma. So S is not an unbiased estimator for sigma. Okay, but we are using S as estimator, a good estimator for sigma. Now, if we are trying to find out the interval estimation, so we require a distribution, and here we are using the chi-square distribution. Why? Because if x1, x2, xn is a random sample of size n from normal distribution, population is normal distribution, so then n minus 1 s square upon sigma square. This value, okay, this formula is what is this? And it follows the chi-square distribution with n minus 1 degree of freedom. So here parameter is what? Degree of freedom, and it is n minus 1 degree of freedom. Okay. So it is again a special case of gamma distribution with alpha is equal to n minus 1 by 2 and beta is equal to 2. So if you remember, exponential is what? Alpha is equal to 1 and beta. Here alpha is equal to n minus 1 by 2. So it will become degree of freedom n minus 1 and beta will become 2. So we fix the one parameter and it will become a special case of the gamma distribution. Okay. So by using that, you can see here when degree of freedom is 1. Okay. So it will become exponential distribution. This is, you can see the curve of exponential distribution. But when we increase the degree of freedom, so it will change the shape of the curve here. Okay. So it is non-symmetric here. So degree of freedom 8, 12, 20, it is the shape is changing of the curve of the chi-square distribution here. So now come to the confidence interval. So in the confidence interval, we are using the concept here, that is the critical value of the chi-square distribution. N minus 1 s square upon sigma square. So do you remember the formula of s square in the last class? That is summation I is equal to 1 to n x I minus x bar whole square upon n minus 1. So this n minus 1 and this minus 1 is cancel out. So s square instead of s square n minus 1 we are using this and divided by sigma square. Okay, Arjun? So the critical value, we can say it is denoted by the chi-square alpha with degree of freedom nu. Okay. So here we can say here, so it is chi-square alpha. Alpha is the right hand side of the curve and degree of freedom n minus 1. Okay. So nu is equal to here n minus 1 degree of freedom here. Got it? Now alpha, as I already told you, the critical value we are getting, that is the alpha, the shaded area, the area of this curve is what? This. So this is a one specific density curve for specific value of nu. So now we can just use this concept here and we can say here 100 into 1 minus alpha % confidence interval for sigma square. Correct? We are talking about the sigma square is what? N minus 1 s square upon chi square alpha by 2. And the degree of freedom is n minus 1. So it is alpha by 2 and this is 1 minus alpha by 2. Okay. So 1 minus alpha by 2 is this and alpha by 2 is this. And we have to find out this separately. Why? Because this curve is not symmetric. So Z distribution and T distribution we have done, they are the symmetric curve. So we are finding only one value and we are saying it is T alpha by 2 or plus minus we are using, plus minus Z alpha by 2 we are using. But here we can't use it. We have to use the chi square Okay. Chi square. Okay, so alpha by 2, one part is we are taking, so this reason is alpha by 2, this part is alpha by 2, correct? And we are using the chi square for the another limit 1 minus alpha by 2, and this is 1 minus alpha by 2. So it means what? We are talking about this complete reason is this part is the alpha by 2, this one, this reason, and the right hand reason is 1 minus alpha by 2. Okay. So what we are saying, the confidence interval is for sigma square when the population is normal distributed, it is n minus 1 s square upon chi square alpha by 2 n minus 1, and n minus 1 s square upon chi square 1 minus alpha by 2 n minus 1 degree of freedom. So only the thing is what is different, the both side is alpha by 2 and 1 minus alpha by 2 chi square. Okay, the right hand side reason we have to consider it very carefully. Okay, so now we are just taking a one example here. One example is n is equal to 7, y bar is 2.48, and s is given 1.13. Now we have to find out 95% confidence interval. Okay, so that is what? N minus 1 6, s square 1.13 whole square upon chi square. 6 degree of freedom, that is 9. N is equal to 7. Yes, it is in the topic in the book. And then it is equal to the 6, and this is alpha by 2, and this is 1 minus alpha by 2. And by the table, I will discuss it later on. Firstly, I will just complete this question. So chi square 6.025, this is by the table, and this is also by the table. So we are just using the chi square table here. This is the chi square table. Okay, so in this one, alpha is provided and nu is provided here, the degree of freedom. Okay, so if you are just going back, what you have to calculate? You have to calculate chi square with 6 degree of freedom 0.025, and you have to calculate the chi square 6 degree of freedom 0.975. है ना? So by the table, now 6 degree of freedom is this, alpha is given here, so 0.025. First we are just checking here 0.975. So 0.975, this value is this 1.237, and 0.025, this value is given this one. So this is 14.440, and this is 1.237. This is the confidence interval for sigma. This is the confidence interval for sigma. Okay. This one. So you can see from the table, you can find out this value. You can substitute in the formula these values, and you will get the answer that sigma square, the confidence interval, 95% confidence. Uh, Sorry, there is some technical issue. I don't know. There is some interruption in the internet. So that's why now are you able to listen me? Okay, fine. Slides are visible? No. Just give me one. Are the slides visible right now? Okay. In this case, actually, what your question is this, that it comes between 0.95 and 0.975. So generally, we are not using them. Okay. It is coming between these only. Otherwise, we can write the two values that it is coming in between somewhere, because we are not calculating here. You know, in the chi-square distribution, the integration is very difficult. है ना? In the standard normal distribution also, we are not doing any integration. We are using the table values. So the table values which are provided, that only we can use. Otherwise, we can't do the question. We can leave that question up to that point, that we have to use this value. Okay. So if values are not provided to you, so it's not possible to do the question, definitely. So generally, in the real life also, we are using the values between 0.9. Just give me a 1 minute, Mr. Vishnu. Okay. So these values are coming here. Now we are just saying for the estimation of sigma. Sigma is what? We are taking the square root of both sides. Sigma square, we are finding the estimation, that is confidence interval. Now we are taking the square root of these two. Okay. So firstly, I'm just taking the break, and then we can come. Then I will just tell you the topic name also. But this is in your syllabus. You can see your handout also. Okay. Break is over. Am I audible? Am I audible? Okay, fine. Are the slides visible? Okay. So we are just doing this estimation for sigma square, and when we are taking the square root of all sides, then it will become interval estimation of sigma. So one example we are doing. So amount of lateral expansion was determined for a sample of 9. So n is equal to 9. Pulsed power gas metal are belts used in LNG ship containment tanks. The resulting sample standard deviation was S is equal to 2.81. Okay, S is provided the sample standard deviation. Assuming normality. So normal distribution is required for our population. So it is given here. So 95% confidence interval for sigma square and sigma. So you know that is what? N minus 1 S square upon chi square alpha by 2 and with n minus 1 degree of freedom, and n minus 1 S square upon chi square with 1 minus alpha by 2 and n minus 1 degree of freedom. This is the our thing. Now we are saying here alpha is what? Alpha is 0.05. We have already done here. So alpha by 2 is what? 0.025. And when we are just taking here 1 minus alpha by 2 is become what? 0.097. Sorry, 0.975. Okay, so we have to see the chi square value at alpha 0.025 with n minus 1 degree of freedom. N is equal to 8, so 8. Okay, and the chi square of 0.975 with 8 degree of freedom. Correct. So here table is provided here, this one. Now for sigma square. Okay, for sigma we are taking square root. If it is sigma square, then there is no need to take the square root. So that is asked for both. Okay, so we are just taking here 8 degree of freedom. So 8 degree of freedom is this. Correct. Now we are just taking the 0.025. So 0.025 is coming here 17.534, and the next one here 0.975. So this value is coming here 2.180. Yes, this is the chi-square table. Chi-square table. So I have taken all small values up to the 10 so that you can identify. Okay. So now we are just taking here the formula here. So 95% confidence interval for sigma square. So n minus 1 S square upon chi square, that is 17.532, and n minus 1 S square upon 2.180. Okay, so that is for this. Correct, for sigma square. And now for sigma, we are taking what? Square root of it. So we are taking here square root of 3.60 and square root of 28.98. So it is 1.90 and 5.38. Got it? So that is the difference for sigma square and sigma. In the sigma, we have to take the square root here. And the table values we are taking from the chi square table. It is provided in your textbook also. So T distribution and chi-square distribution and Z distribution. These three distribution we are using here in the interval estimation as well as in the hypothesis testing. Okay. Is it okay for all? Any query, any doubt? So simple formula based, only you have to know what is given, what is asked. So one by one, you just note down the points, what is given and what is asked and which formula is applicable. That is the most important thing here. And there is no need to remember the formula because it is an open book examination. Okay, so book is allowed. As I told you, we are using three distribution. So three tables are provided. You can use Z distribution, T distribution, and chi-square distribution. It is not given in the book. I will see the book. Just give me a 1 second. I will see your book is what. One second. Actually, just give me a 1 minute. I will find out the book and then I will. I think one student send me the book. I have to find out that book actually, and then I will check because I have the only the hard copy which I took from the library. So the topic you were asking, that is given as 6.4, the sampling distribution of variance. So the topic which we are doing here, it is 6.4 here. And the table which is provided here, I will see that appendix table. Just give me 1 second again. Appendix statistical table. You can see binomial table, it is given here. Second is given as T alpha values. So you can see the page number 5 to 8 in my book, which one student shared with me, the ebook. So it is 5 to 8 page number. T distribution table is provided. Okay, after that, the is not different. 1 minute, I will see somewhere else the values are given. Yes, you can see here. Standard normal distribution table is provided. Standard normal distribution table, table 3. It is provided on page number 550. And then we are just moving back. Okay, this value is not provided here. I think it is not provided in the this ebook, but I copied from this, so it is provided in the hard copy. It is provided in the hard copy. Okay, so I will check. I will provide the values of it also. Okay. Page number 5 to 8. I will just find out. Okay. Yes. Chi-square distribution, degree of freedom is given here. And the table is also provided. Okay. Page number 5 to 8. That's a good news for you. So you can take the PPTs of the provided, because on the PPTs it is mentioned, and every PPT there is a brand name is mentioned for BITS planning. We are not taking the PPTs of another type of this one, है ना? So you can go, you can take the this print of the PPTs, which you are saying in the initial classes of this one. So it is already. Yes, you can. No, you can't take it to your notebook. You can take only the printout of the PPTs and the hard copy of the test book. Alpha is equal to 0.95 is not given. It is not watermark, but the brand name is mentioned now. Watermark is coming on this page. Basically on this page we are just taking a watermark. So it is not watermark, but you can see here that BITS planning values are given here. Okay. Which type of, what is your question? For which type question, ma'am? For any trick or trip for the easy identifying, ma'am. Which type of question means what type of formula you can apply, na? So we are just giving the summary for that also. We are trying to give you the summary for that also, na? That okay, you have to use this formula, you have to use this formula. We will provide you. Correct? I don't know this table. I am not able to get on my ebook copy, so I can't say anything. I don't know, but you have to take your so you have to take your hard copy, and in the this is I'm a bit sure that it is provided in the hard copy actually. Okay. Any other query? So we are just doing 7.3, that is the interval estimation. And we have also done the 6.4, that is the variance, related to the variance. And now after that we will start the test of hypothesis, null of okay. So I think I have to just cover this one. So that is confidence interval for population proportion we are not doing here, because it is given somewhere else in your textbook. Actually, it is given in the exercise. So, okay, we can just remove it from your. Okay. In the hard copy, in the 9th edition, I have this copy, and I found the table. Okay, if you have the problem, so what I will do in the examination, in the question, I will provide that type of hard this copy, this table. Okay, as in the closed book examination, I provided the table now for the binomial distribution. So definitely, if there is any question related to that for the chi-square distribution, I will provide you the required part of the table of the chi-square distribution, because that's great that you have informed me that you are not able to find out. Okay, so I will provide in the question, not that is completely solve your problem. In the question paper itself, you will get the table values, identify the required table values, and put it in the है ना? That would be the last option that we are using as in the closing book. But I am providing only for the chi-square distribution because you are not able to find out the table. But T distribution and Z distribution values we are not providing to you in the examination. Okay. No, I will not forget, definitely. If I forgot, so you just leave the question as it is. है ना? Don't put the values of the table and you just write it. Okay, we are putting the table values and we will get the answer. Only 2 lines you will write. Accordingly, we can check the solution. Don't worry about it. ठीक है ना? So don't worry about these things. If table, I already told you. Okay. I am always trying to give you the easy question. In the EC2 also, I gave you the very easy questions. If you are seeing the on-campus question paper, so you can see the level. Okay, so that's why I'm trying to give you the easiest questions, whatever is the possible. And I am also trying to give the questions so that there is no need to remember so many formulas. Okay. Similarly, here there is no, it is open book examination, so no need to get the Mr. Nilesh, actually, makeup examination, the copies are in the checkup, in the checking process. So when they both were done, then they will just open for the this your copies for the you can see your copies with the marking scheme. Okay. So in the next class, when we are open for the your answer key, when we are just open your the answer sheets now, at the time I will upload this on the Teams and as well as on the eLearn portal, the answer key. Yes, definitely, Mr. That some marks for step marking is provided, but steps are also should be correct now. Marking scheme, that is a step marking scheme is done. Don't worry about it. I can understand your problem, but please try to understand my problem as well, because I have to give the questions at least, which are not done in the lecture classes. But you can see the questions, level of questions which we had done in the PPTs in the exam on the lecture classes, same type of question we are giving, and very easy, just a calculation base, a small calculation. No, actually, because I am not putting the that slides actually. So writing PPT is not allowed, I believe. And there is not need to in the mathematics course, because you are doing the practice. So you have to just see the concept only on the slides. So there is no need to remember the formulas. Main concept is this. Doing calculation is your own. And in the exam time also. There is nothing theory in that okay, you have to just copy this story to on your answer sheet. It's not done in the mathematics. You have to solve each and every question in the examination. So you have to see what is the formula, what is given, and what is what we have to find out, and accordingly you just go for it. So in the next class we will do the this is 13 now. So in the 14 class we are just doing the maximum likelihood, then hypothesis testing, the 7.5, and then in the last class we will do the regression analysis. Okay. What is the meaning of pass marks? In BITS planning, there is no marks for consider as pass mark. That is 33%, 32%. It is not like this one. It is a relative grading. No, 3 more classes, 14, 15, 16. This is the 13th class. Step marking done. You can see the marking scheme. Mr. Bishnu, we are doing this as a statistics part only. This is a statistical inference which we are trying to do, that point estimation, then interval estimation. I am trying to recover it. Mr. Venkata, thank you for your concern.